A few months ago I started this year 2000 Dream Machine project. It's a recreation of my ABIT VP6 rig from back then. We have repaired the motherboard in previous videos and resprayed the Chieftech Dragon case in this sparkling green color. In today's video we're going to repair and upgrade the graphics card to finish this project. Okay, let's start with the graphics card. For this build we went period correct with the GeForce 256. That's a pretty perfect match for the period. However, this machine is powerful enough to take something much faster. So I have picked a few better options. The most likely card to have been the last card in my original machine was probably a TI 4200, so that's one of the contenders. But the problem is, all these cards are actually broken. And unfortunately, these are not the only vintage cards in my collection that have stopped working. So something bad is happening to my old graphics card, and we need to find out what it is. The 4200 here is mostly working, but it adds some weird dots on the display. These two I can't quite remember, but some of the caps are bulging on this card. So let's start fixing stuff and see if we can figure this out. Let's start with this guy here. So this is Gainward, GeForce 4 TI 4200, 64 megs. I'll insert something on the screen here to show you what the issue is with this card. This board has a mix of through-hole and SMD caps. So I'll start by adding some fresh solder while the desoldering gun heats up. Wow, this card has some pretty thick ground planes. Yeah, solder gets stuck. I hope I don't have to preheat the entire card. Well, let's give this a try and see how it goes. Here it goes. Yeah, I think that through-hole cleared out. This card has a really thick solder mask, so it can take some wiggling without getting damaged, unlike some older PCBs. I tried to remove one of the caps without first adding some fresh solder, but that didn't work at all. So I added some. Now let's try again. This guy was really stubborn. I added fresh solder twice, but it didn't help. So let's add some heat and see if we can get that cap unstuck. Yep, that totally worked. There is, however, still some solder left in the through holes, so we can't install new caps right away. I'll add some leaded solder and let it mix with the old solder. And then I'll heat this corner up. So the issue we're having here is that the ground plane sucks up all the heat, and there's not enough heat left to get that stupid solder out. Okay, but I think this is working. I am of course skipping ahead here, but I'm waiting for about 10 seconds before I pull the trigger. No, that actually didn't work. Wow, that is one stubborn card. I've got so much stuff on the bench. I really don't want to bring out the preheater. So let's instead add more fresh solder and preheat just this area with the rework station. And then try again. Wow, no, that still wasn't enough. Holy crap. I may have to bring out the preheater. That means I need to clean up my bench. Oh, that sucks. Okay, that one actually cleared out. Well, in that case, let's give this method one last try. Okay, on the third attempt, it finally worked. Well, in hindsight, I should have used the preheater. Okay, no ugly scratches, despite my wiggling. So I have saved at least one board by replacing caps with this brand before. So let's hope for the best. These are 1000 micro 6.3 volts. I just realized, I think we have an issue here. Whoever designed this board gave himself a lot of options for different types of caps. So aside from the through holes, we also have pads for SMD caps. And for this project, I ordered poly caps. And if I'm not mistaken, this housing is conductive. Actually it isn't. That's a bit of a surprise. It looks like aluminium, but it doesn't seem to be conductive. What kind of wood is this? Yeah, this housing totally looks like aluminium, but apparently it's not conductive. That's strange. Doesn't look like it has any coating on it either. So the original caps here, they seem to have some kind of clear coats, but if I scrape it away, they are actually conductive. So I guess it's the same thing here, but they're not glossy, so they don't look like they are coated. Well, if the housing isn't conductive, they shouldn't short the two pads. But I have to say, I really don't like the look of this. Unlike many other boards, the silk screen is marked on the positive side, so I always check before I remove caps. So polycaps have a superior performance and a much lower distortion and a much longer lifespan compared to electrolytics. I've actually never had a polycap go bad so far. They are a bit more expensive, but I think it's totally worth it. Wow, it takes forever to heat up the pads on this board. Well, that coating is doing its job, so the pads are not shorted. Next up we have these two guys. They were actually a lot easier to desolder. Now these are a bit odd. They are marked 510 and 4. That's a strange value. Let me see what I ordered. Okay, apparently I ordered 560 micro 4 volt caps. What a strange value. I can't recall ever replacing a 510 microfarad cap before. Now let's see if these are easier to solder too, since they were a lot easier to desolder. Yeah, those pads are heating up a lot faster, so hopefully the rest of the caps on this card are going to be this easy too. Okay, so those were the only through-hole caps on this card. So let's take care of the SMD caps next. So we've got these two 330 micro 6.3 volt caps. I'll start by adding some flux to the pads. And then I'll grab the tweezers and place a blob of solder on each tip. Now let's see how the tweezers will handle that thick ground plane. Well, not too bad. It took a bit longer than it usually does. And there are actually optional through-hole pads underneath this cap too. So how about this guy here? Well, not too bad either. So the SMD caps were actually a lot easier to remove than the through-hole caps. But they left some large solder blobs on the PCB. So I'll go ahead and remove it with some wick. And I'll remove the flux with some IPA. As good as new. I'll heat one of the pads up and add some fresh solder. I'll reflow the solder and add a fresh cap. Then I'll just solder the other pad. Okay, next up we have these big guys here. These 1500 micro 6 volt caps are huge. Let's see if my tweezers are powerful enough to remove a large cap like this. Well, sort of. It's taking quite a lot of time, but eventually it came off. These guys are really big. There's a comparison to one of the other caps. These large caps didn't have any optional through holes. So SMD caps is our only option here. I better clean up that messy mess before we install new caps. And apparently I ordered 1500 micro 6.3 volt caps. And these guys are actually a tiny bit larger still. But we've got plenty of space here, so that shouldn't be a problem. Okay, next up we have a somewhat smaller 1000 micro 6 volt cap here. So removing a cap with the tweezers only takes a few seconds on many boards. But this card here is so filled up with copper, it takes about 15 seconds. Adding some extra heat to this card would have made this recap much more enjoyable. But this is doable. And my replacement cap is a 1000 micro 6.3 volt cap. Actually, I may have found something interesting here. Check out the pins on these two chips. That is actually some mild corrosion. I didn't notice this before, But when I removed the last cap here, I did. That is clearly corrosion. And one common cause for corroded pins is actually leaky caps. So maybe we're onto something here. I'll add some flux and reflow the solder on these pins. Because if that is electrolyte, it has to come off. Otherwise it will continue to eat away at the solder and the chip legs. I'll add some solder to the tip. Then let the flux do the job. And now those chip legs are nice and shiny again. I don't spend too much time cleaning up the flux. I'll just remove most of it, because I plan to wash this board when we're done. And our last cap is this beefy 470 micro 25 volt cap. Apparently I had to go with a different brand. All the other caps are Chemet brand. Okay, the recap is done, but before we test the card, I'll pull these two tabs off and now we can remove the fan. Actually, it's not too bad. It's still kind of soft. So I've seen a lot worse, that is for sure. So let's go ahead and replace it. And this is the part of the video where you're supposed to leave a comment and tell me that I'm using too much. And I'm going to do my best to ignore it and instead reinstall that fan. Okay, we're ready for a test. Okay, let's install the freshly recapped ATI 4200. And let's power up the mean green machine. Oh no, we still have some random dots in the Energy Star logo. Oh crap, it wasn't the caps. And tons of extra white dots. Oh, that sucks. And in Windows, we still have those stripes. Well, I've had some strange artifacts on another machine that had bad VRAM. So I actually tried to find some of these RAM chips on eBay and AliExpress, but unfortunately I couldn't find any fast enough. There are plenty of these on eBay that can do 166 MHz, but these guys, they are good for 300 MHz. So I guess I'll keep looking, and maybe there is something compatible we can use instead. And hopefully I will return to this card in a future video. And our next contender is this 9700 card. I'm not entirely sure which version this is, but I think it might be a TX. These cards are a bit difficult to identify, because it doesn't actually say anywhere on the card what it is. This card is a black screen, but we have a clue to what might be the issue here. Someone has definitely dropped this card. One of the pins isn't even attached to the card. So I guess I'll replace the caps on this card too. I'll be skipping through this one quite quickly, since the process is about the same as with the GeForce card. Some of these caps don't have any components nearby that can be damaged by heat. So for comparison, I'll use a Rework station, at least on some of these caps. Actually, this is taking a lot longer than using the tweezers. And yet, I actually added some fresh solder to the pads. Yeah, this guy is really stubborn. I am of course skipping ahead here, but this is taking a lot longer than what the tweezers did on the previous card. So I guess this card too has a really thick ground plane. This is getting silly. Yeah, there's no way this method is better. So this is not going to be a perfect comparison, since the board is now hot. And that took about 15 seconds. So way faster than with the Rework station. And with some bigger tips, I think this method is even better. Yeah, that only took like 10 seconds. But now this area of the board is hot. So it should be a bit quicker. Oops. Okay, these are worth mentioning before I continue. They're marked 470. But there is no voltage marking. However, they have a letter J. That J means 6.3 volts. That could be useful information if you're playing along here. Okay, that was actually the last cap. The pads on this card, by the way, they are absolutely huge. Never seen pads this big on any PCB. The heat paste on this card has dried up completely. This stuff has turned into cement. Took some serious effort to remove it from the die. So I'm actually going to leave what's left on the sides here, because I don't want to risk damaging the die. But I will of course remove this stuff here. Okay, black screen, 9700 something, fully recapped. Okay, here goes. Okay, we're getting some weird beeps, but unfortunately absolutely nothing on the screen. So that card is unfortunately still a black screen. Well, that sucked pretty bad. And that also means this guy here is our last hope for an upgrade today. And again, I'm not sure exactly what card this is. Quite possibly a 9600 Pro. Some of these vintage ATI cards are very poorly marked. R96 and 128 megs is marked. Well, hopefully we can fix it, and then we'll find out in software. And again, we have a clue to what might be the issue with this card. Check out these guys here. They are clearly bulging. So if you look at this cap here, that electrolyte is on its way out from that cap. Now let's see if we have some cement underneath that fan. Well, it's a much smaller die. And yeah, for sure. Same thing on the fan here. This stuff has turned into cement. Let's see if it will come off with some IPA. It does, actually quite easily. I'll leave what's left on the sides here, because I don't want to stress that die. Okay, and this is an RV350 chip. So maybe my guess is right. This might actually be 9600 Pro. I'll add some leaded solder while the desoldering gun heats up. And then we'll find out if this card sucks up as much heat as the other two. Only 3 of the caps are through-hole caps, and the rest are SMD caps. I did Google these numbers, but that was not enough to identify the card. No, same issue here. So I'll preheat this area and desolder those caps off camera. Yeah, check out these guys. They are actually bulging even more underneath. So these are definitely bad caps. And it's actually that brand again that I have had issues with before. I'm gonna go with poly on this card too. And hopefully these are not wasted. Okay, body is fully recapped. Now let's add way too much heat paste and get lots of comments. That should boost the algorithm and finally make me famous on YouTube. Okay, time to test the mystery RV350 card. Here goes. That is an incredibly noisy fan. I'm gonna have to fix it if this card works. Oh, we got something on the screen. Well, it's a bit messed up. It's all compressed to widescreen, but maybe that's normal for this card. But that awful noise is definitely not normal. Okay, booting to Windows, and it's still working. Holy cow, that fan is totally shut. Yes! Success! We are in Windows and the picture is perfectly normal. Oh, did that fan just die? Let me check. No, it didn't. It just stopped making noises. So maybe the grease was just a bit dried up. Let me find some drivers for this card. We'll check it proper and see what the heck it is. Okay, I found some drivers on the retro web. Okay, it recognized the driver. There's something fishy going on with this driver. It's asking for this file here, but it has been renamed. So let's rename it back to its original name. Okay, that trick worked. Okay, Radeon 9600 series. But which one? Okay, it's done, but I still don't know which card it is. So let's go to the device manager and check. No, it only says 9600 series. In that case, let's run GPU Z. No, same thing in here. Just says Radeon 9600 series. So I guess I'll check the speed. That should tell us what card this is. Well, it's running at 300 megahertz. And the memory is running at 200. Let's see if we can figure this out. Well, I'm checking online here, and it's definitely not the XT. And it's not the Pro either. It's running at 400 megahertz, just like the Pro. But the memory is only running at 200. And RAM on the Pro should run at 300 megahertz. And it's not a regular 9600 either, because that card runs at 325. And this card here is running at 400. Well, it's a 128-bit card, so I'm pretty sure it's not the SE. But I guess this could be some kind of weird OEM version of the card. Okay, I'm running a game here as a final test. And it runs perfectly smooth. So that card is now totally working. Awesome. So finally a win. And obviously, if you know what card this is, then leave a comment. Okay, let's do some more upgrades to this machine. Because I actually have some issues with a couple of things here. I keep getting these weird conflicts with the USB hub. And sometimes the machine crashes when I have a USB stick installed in the machine. The easiest way to get software on a machine from the early 2000s is by using a regular USB stick. So for that reason I have installed a USB hub in the front panel to make it as easy as possible, so I don't have to lean over the machine every time I need to install a new game. The USB hub is of the old style, so it's connected with a regular USB cable inside the machine to this VIA card. And here's where I think we have the issue. There are two possible explanations here, as suggested by many viewers. This chip may be pretty crappy, or this could also be caused by a conflict, because the motherboard also has a VIA chipset. So, as recommended by several viewers, I bought this card instead with an NEC chip, and supposedly these are much better. So I'll swap it and we'll see if the conflict goes away. Okay, the card is recognized. Windows was unable to locate the driver for this device. Oh crap, apparently Windows 2000 doesn't have drivers for this card. Okay, I found some drivers on the retro web. Let's give these a try. Windows found a driver, generic USB 2 hub. Okay, I think that worked. Let's reboot and test it. Okay, let's install USB stick and see if this works. Okay, I think it does. Yep, there's our USB stick. Awesome. Now let's check for conflicts. No, nothing here. Awesome. So thanks to everyone who left a comment about that VIA card. I think this totally fixed it. Okay, so this project is a recreation of my original VP6 back in the 2000s. So to finish the project off, we need to restore this mouse. This was actually the hardest part to find for this project. But I'm a patient guy, and after a few years I finally found one. But unfortunately the switches are completely dead. And all the rubber had gone very sticky and disgusting. But I washed it in IPA and then in warm soapy water. And now all the stickiness is gone. And I also ordered some Kyle GM 2.0 switches. There are plenty of reviews on YouTube about these switches. And from my understanding, these are pretty good. These original switches are Zippy brand. And they are marked 0923C. So apparently not very good switches. Or I guess someone could have spilled something inside those switches too. I added some fresh leaded solder on all the pins. So this should be a quick and easy repair. That switch got burning hot. Okay, let's get rid of these crappy switches. Well, this one is a bit tricky. It has this plastic hinge with a spring, and it's pushed by pushing on the mouse wheel. Okay, let's see if we can figure this out. That was pretty easy. And our brand new Kyle switches. The reassembly was a bit tricky to get on camera, but it wasn't too difficult to do. Okay, that was the last switch. So now I only need to remember how to reassemble this mouse. Okay, apparently not so easy. So this is how it works. The switch has 2 holes on the side. And the mouse has 2 corresponding pegs. And this switch is then installed by pushing it on top of the pegs. But these new switches, they have smaller holes. So it won't fit. This only affects this switch here. So I'm either gonna have to reuse one of the old switches, or we could try to drill and enlarge those holes. If the switch breaks, I'll reuse the old switch. Well, it seems like it worked, but let's see if it fits. Not quite. Well, I didn't see anything break. So maybe that worked. Yes, it did. Okay, that was not the last problem with this mouse apparently. So the previous owner has used this mouse so extensively. The plastic bit here that pushes on the micro switch is so worn. The middle part of it doesn't quite reach the switch. This mouse was owned by some serious gamer back in the day. Let's see if we can fix this too. Okay, let's see if I can get this on camera. So here's the switch. And here's the left mouse button. And that plastic bit is supposed to push on the micro switch. And hopefully you can see that it has been so worn. It just goes on top of the switch instead. So I think the easiest way to fix this is to just sand this stuff off and make it even again. This will make the mouse button go further down before it actually pushes the switch. Okay, said and done. I grabbed the file and filed away a tiny bit of that piece. This should now work. This will affect the mouse slightly because the left mouse button will now go 0.5 millimeter further down. But I don't see that as a problem. Let's say this is fixed. Okay, let's see how well this mouse button works. Yeah, no issues whatsoever. That totally worked. Awesome. So now I have the original mouse, just like I had back then. Funny how that was the most difficult part to find. Well, we're not quite done yet, because we haven't overclocked this machine yet. So you can expect this mean green ABIT VP6 project back on the channel in the future. But that's all I had for you this week. And I'll see you guys again next week.